So, good morning, everyone, and welcome to the new class today. I hope you had a wonderful long weekend. So, today we will continue with the applications of the biomedical signal processing. Today we will discuss about the application of the speech signal. Speech signals means whatever we talk, how we talk. So, we can give command. Nowadays, you will find that there are various devices. The one of the very commonly used device is Alexa, right? Okay. So what does the Alexa does? We give voice command, it recognizes it, and then it processes the signal, speech signal, and then depending upon that, it recognizes what command has been given, and using that command, it generates control signal for different appliances. Say for example, light. Say for example, your fan, AC, whatever you want. The same thing you can design on your own. Okay. So herein we will discuss about one of the home automation system which has been developed by one of our students. Okay. So application of the speech signal for controlling वॉइस कंट्रोल्ड होम ऑटोमेशन सिस्टम. यहाँ पे कंट्रोल्ड होगा वॉइस कंट्रोल्ड होम ऑटोमेशन सिस्टम. ओके. So why this is necessary? The first question is why this is necessary? Why such kind of systems are necessary? You will find in our home there may be various differently abled person or aged person who cannot get up from their bed, or they have very restricted movements left within them. Because of that, they are either bedridden or their movement is restricted in a very limited area. So suppose if they have to control the operation of some appliances, say fan, say TV, say for example AC, etc. So in these cases, what happens? They are totally dependent on another person. Now, if they are dependent on the another person, you have to keep some caregiver who will take care of all these things. However, in many cases, you will find, especially in the Indian scenario, that this is not possible. Why? Because many of the families in India, they are lower middle class family. Okay. Because in Indian scenario you will find the middle class family, it is more predominant, and within this middle class family also you will find the lower middle class is much more predominant. Okay. So what happens, they can maintain their regular day to day life activity. However, if you give them extra burden, extra medical burden, it becomes difficult for them to live a very what do you call, a very healthy life. Healthy life means a good quality of life. Okay. Because if you see nowadays, in especially in the metro cities, you will find both husband and wife, they are working to fulfill the needs of their families, right? Now why this is happening? This is happening because our India, it is growing, economically developing. Now since it is economically developing, the standard and the quality of life, it is also increasing. Now when your standard and quality of life increases, your expenses also increases, right? Now to meet these expenses, both husband and wife, they have to work together to maintain this quality of life. Now over that, if you think that we have to take the help of a health care giver, it becomes very difficult for these families. Now if you go to any of the schools, if you want to teach your kids to any of the good schools, you will find that it is too costly. So everyone wants, whether he is a poor parent or he is a billionaire, everyone wants that this their kids, they should be studying in a very good quality. They should be studying in a very good quality school. Okay, where they can learn many things, especially the spoken English and all these things, right? Now everyone tries their best. Okay, so to maintain all these things, they have to work. Now if you add up these healthcare problems onto that family, especially when they are having parents with them, so what happens, it becomes difficult for them to maintain that quality of life. And it is not only to the middle class. If you think of your a person who is residing in a chawl. Chawl means what do you call, uh, a shanty like thing. So in that, what happens, they also have elderly persons in their home. So how do they manage? So these electronic devices, especially these voice controlled home automation system like devices, if you can develop it at a very low price, then this can help those this diseased person or the differently abled person to live their life independently to a certain extent. Okay, I am saying independently to a certain extent. I am not telling that their disability or their what you call, their diseases will be cured, especially if it is an age related disease, it will be cured completely. But I am saying, if we give them some kind of independence so that they can maintain their lifestyle in a better way, so that they are not dependent on the other people, in that case the financial burden on the family, it comes down to a very lower level. Okay, so in these cases, so we can design, being biomedical engineers, we can think of different devices which can help them to reduce this to increase the independence over the other person. So one such example is this voice controlled systems. And Alexa, it can also help it because it is already commercially available. But the problem with Alexa is that it is quite costly. Okay, but if you can design it at a lower price, that can also help you. So in that regard, before the Alexa came, one of our student, he worked on such kind of system. So what he did is that, let me go over here directly into the this flowchart, how the device acted. So we, everyone nowadays, they have mobiles with them. Okay, in the mobile, the student, he developed an app. Okay, now this app was developed, and this app, it was interconnected with the speech recognizer of Google. Okay, speech recognizer of the Google. So when you activate this app, so what happens, this Google speech recognizer, it gets activated, and when you speak, it will convert the speech into text command, and then the other thing will happen. Okay, so we can see this smart mobile phone, it plays an important role. So how this voice controlled home automation system, it works? In my last class, I told you, when we are talking, then also speech are being generated. Now, how this app, it will determine whether you are speaking to the app or you are speaking to someone else. Over here also, what we did is that we used a magnet to activate the a Hall effect sensor. I hope everyone knows what is an Hall effect sensor. Okay, Hall effect sensor, everyone knows? You don't know? Don't know? So can you tell me what is a Hall effect sensor? Uh-huh. Sense? Hall effect sensor? No. Incorrect. Anyone else? No? Okay. So Hall effect sensor, it is basically a sensor which senses a magnetic field around itself. So it is a three-legged sensor. Okay. And it acts as a switching device. Now, when this magnet, it is being brought near to the Hall effect sensor, what it does, it generates a control signal. So when the person, he needs to interact with this Hall effect sensor, so what you need to do, the person needs to bring that magnet towards the Hall effect sensor, okay, and then it will generate a control signal, and this control signal will be transferred to Arduino, which is a microcontroller. Okay, so this microcontroller in turn, it will send the control signal to the mobile app through the Bluetooth module attached to it. Okay, so this Bluetooth module which is attached to the Arduino, which is a microcontroller, can be paired with the mobiles through the Bluetooth communication technology. Okay, nowadays you will find these Bluetooth headsets and all these things are there. So how this is possible? This is possible because through the Bluetooth technology you can pair the devices and you can use them as the wireless devices. Now once it is there, so what happens? The activation signal, it goes to the app gets activated. Now once this app gets activated, the speech recognizer module, it is being activated. Then we need to speak the command, it converts it to voice to text. Now this text command, it will be sent via this Bluetooth module again to the Arduino. Okay, now based on this, what it will do, it will generate the control signals for the home appliances. Over here we have kept as USB powered LED lamp and USB powered fans as the representative appliances. Okay, so I hope you have understood. The person, he brings the magnet towards the Hall effect sensor, it acts as a switching device. Now this switching device, it generates the control signal for the app. Now that signal, it is sent to the Arduino. This Arduino through the Bluetooth module sends this activation signal, which is basically the control signal generated from the Hall effect sensor, to the app. App initiates the speech recognizer module. Speech recognizer module recognizes the voice. It converts it to text. That text is sent to the Arduino, okay, which is again the microcontroller through the Bluetooth module, and then it generates the control signals from here to put on the lights or the fans across the home. Now you would say, sir, in Alexa it is not needed. Okay, so now why we have to add it over here? Okay, so the thing is that if you look into the Alexa, when you give command to the Alexa, what we have to do? We have to say, Alexa do this, Alexa do that, whatever. Okay, now what does the Alexa does? It continuously runs. Okay, the device is continuously in the powered on mode. Okay, so it is continuously getting the power, and when it learns the word Alexa, it is the activation signal for it. Alright, okay. Alexa is the activation word for it, and after it recognizes this word Alexa, it initiates the this what you call the control signal generation mechanism within it. Okay, so this is how Alexa works. So over there, if you see this control system, what we generated for the activation of the speech recognizer module, it is slightly different than that of the Alexa. Okay, so you can go for either of the stuff. And okay, now this is the app which the student developed. So there would be some modules like this one where you need to speak. So over here your Bluetooth is connected, and it would say speak now. So when you speak, it will whatever you say, that command will be shown just below there. Okay, so over here first command was given as all on. That means both of them, both fan and the USB light, it was activated, and in the second command both of them were put off. Okay, so let's see the demonstration over here.
This is a prototype voice controlled home automation system designed for locomotor disabled subjects. The system primarily consists of the Arduino board and its related program, the specifically designed printed circuit board for the circuit, which mainly consists of the Hall effect sensor, the HC05 Bluetooth module, the interconnection ports, indicator LEDs, and the USB port for connecting the loads. It also consists of the Android app specifically designed for this application. How the system works is that when I move a magnet in the vicinity of the Hall effect sensor, it generates a signal which goes to the Arduino board. On receiving this signal, Arduino board issues a command which goes to the Android app via the HC Bluetooth module. On receiving this command, the Android app launches the speech recognizer, and now the subject can speak his command into the app. This command is then converted into text, and this text is again sent back to the Arduino program via the HC05 module. Here the Arduino program ascertains what command has been received and then takes the corresponding action. We should have a small demonstration. All on. As we can see, on activating the system and giving a command, the system recognized the command and the loads were made on. Now, on giving the off command, the loads should go off. All off.
So you could see that when the all on command was given, so these both light and fans they started to operate, and when all off command was given, both light and fans they became inoperational. Okay, so in that way you can also go for this light on, light off, fan off, fan on. So whatever, it depends upon what type of command you want to generate, that is upon you. Okay, so in this way it is possible that we can develop voice control home automation system at a very low cost, because one Arduino it costs you around 500 rupees, and again the Bluetooth module again 600 to 700 rupees. So just by investing this much of money, it is possible to develop uh, pretty advanced systems for controlling the home automation devices. Okay. So coming to the next application, EOG, the application of the EOG signal. Okay. So herein we have EOG. I already told you, electro-oscillogram signal, and in the electro-oscillogram signal, it can be used again to generate control signals for manipulating various devices for rehabilitation purposes. Say, for example, robotic vehicles, motorized wheelchairs, okay, robotic arms, right? So in that way, we can look into the stuff. So what happens over here is that we place electrodes. So these are vertical electrodes. These 2 points, when we place it on the top of the eye and at the bottom of the eye, so they are vertical electrodes. Then these two electrodes which are placed on the two sides of the eye, they are called canthi electrodes, okay, or horizontal electrodes. So the vertical electrodes, they are responsible for sensing the vertical movement of the eye, whereas the horizontal electrodes, if I name it AB is for the vertical electrodes, they are for the detection of the vertical movement, whereas C and D electrodes, they are for the detection of the horizontal movement of the eye. Okay. So there are other ways. Suppose if you want to find out at this location, then both C and D, C and A, they would give you some reading. Also, this what do you call? If you look into this towards the nose, if you move your eyes towards the nose, then the B and D electrodes, they will also be giving some reading. Okay. So you have vertical electrodes, vertical signals, and horizontal signals. Okay. So A and B, it will take the differential signal and it will generate the vertical signals, and say A and B. And similarly, if you take C and D, it would take it will give you the horizontal signals. Okay. So what operation is happening? So here the biopotential amplifier, it finds out A minus B or B minus A, whatever, and here it finds out C minus D. Okay. So when you are moving in the vertical direction, this A minus B, it is larger. When you are moving it in the C minus D in the horizontal direction, the C minus D, it will be some what do you call legible amount of, or legible value of the potential will be detected. However, if you move in other directions, so in both vertical section and the horizontal sections, you will get some values, and when you will be getting some values, by analyzing the signals, you can develop an algorithm to determine what is happening over there. Okay. So what happens in EOG controlled devices? So the EOG signals, they are being generated. Okay. These EOG signals, they are being captured by the electrodes, and then we apply the filtering and the amplification. Okay. So this is a part of the signal acquisition system, and after this there is DAQ, which helps us in taking the signal into the computer, and in the computer we go for the processing, say signal classification, where we go for blink detection, or we apply a logic for detecting the eye movement direction. Okay. From there, from these two things, if we develop the logic, we can generate control signals. Okay. we can generate the control signals which are then mapped to generate the control signal mapping. So bias signal, you have generated a bias signal, then through this logic a mapping is done to generate this control signal. Now this control signal, this is used for manipulating the rehabilitation aids. Okay, say for example, over here if we talk about a wheelchair, in our case we have used a robotic vehicle which was having two motors M1 and M2. Now if you see, when we say mapping, so what is mapping basically? So when we are moving our eye up, it should generate control signals so that the motors M1 and M2 which are there in the robotic vehicle, they should perform certain operation, and we have mapped that when our eyes are moving upwards, our wheelchair, it should move forward. Similarly, if we move our eyes down, the wheelchair should move in the backward direction. If we move our eyes right, the vehicle should move right. If we ever move our eyes to the left, then the vehicle should move to the left. And if we blink, then it would uh, initiate the what you call, it would initiate the system itself. And then once the system is initiated, then these operations can be performed. Okay, so what is the flow chart again? Electrode for horizontal signal detection, electrode for vertical signal detection. See, horizontal signal eye detection has been made, vertical eye signal detection has been made. Then through the data acquisition system, it goes to the computer. Say it goes to the computer where we have lab view signal processing system and generation of control signals. These control signals again through the Advantech DAQ. Advantech is a company, DAQ is a data acquisition system. It goes to the hardware where we have control signals being generated in the hardware. Then there will be encoder, there would be RF transmitter. To the RF transmitter, wirelessly the signal goes to the RF receiver module. Then the signal will be decoded over here. Who will decode it? Microcontroller will decode it, and this microcontroller will again decode these control signals, and it would drive the motors M1 and M2. Okay. Now this is how it works. See, the electrodes are placed at these locations. Okay. Now there is another electrode over here. This electrode is regarded as the reference electrode. This is the reference electrode. Okay. So in any electrical potential signals, you will find that there is an active electrode and there is a reference electrode. Okay. Now the thing is that in our case, I told you that for the detection of the vertical electrodes, we need two electrodes, A and B. Now we are converting into such a system so that the output of this system is A minus B. Okay. Now since it is A minus B, we have basically converted it into an single potential. Okay. But this potential, it has to be measured through a reference. So this reference value is over here. But you will say, sir, how will you measure single potential? It is not possible, right? The thing is that when I say that A is a potential, A is a potential because what we are doing, A minus 0 is equal to A. So what is this 0? This is 0, nothing but the potential at the reference electrode. We are considering that the potential at the reference electrode, it is 0. That's why we are getting A voltage at the A electrode. Okay, and then we are getting A minus B over here. Okay. So similarly, in the horizontal electrodes also, the same kind of thing will happen. There will be two electrodes. There will be again the reference electrode. However, since we are making only a single system, we take the reference electrode as the common reference for both the systems. Okay. Say for example, you have a TV. In the TV, there are various components. One, you have the control panel to receive the signal. Then you will be having some control systems or the processor which will be displaying the picture onto your LCD screen, okay, or the LED screen, whatever. So in these cases, what is happening in the whole TV? If you plug it into your socket, do you have separate reference points or earthing, what we call it? No. Sorry, not earthing, the neutral. So it is, we have only one neutral and one active here. So when we are devising a system, it has to be clear in your mind that the reference point should be only one. Okay, the reference point should only be one. Now over here, we place the reference at a far off distance so that it does not interferes with the recording of the vertical and the horizontal signals. Okay, so by moving the eyes, you can see different signals are being generated, different types of signals are being generated, if you see over here. And ultimately, after processing, you will find different LEDs, they are being blown. Okay, so that means the processing what we have done in the software, it is good enough to generate different types of control signals. Okay, now once that is done, you have the output for this ABCD, this thing, this ABCD, this outputs. So what are these ABCD outputs? These are the microcontroller outputs, and based upon these parameters, our motor, it will either move towards the in the clockwise direction or in the anti-clockwise direction. Okay, so in that way, I think forward. Yeah. So forward direction. So this is in the clockwise direction and the anti-clockwise direction. So why this is so? Because if you see, suppose I am having this motor. So suppose it is moving in this direction. Now, if I move it in the other way around, so what will happen? It would become anti-clockwise. Okay. So this is because of this reason we are having this right motor moving in the clockwise direction, and this is in the anti-clockwise direction. However, when you fit it into the robotic vehicle, they both move in the same direction. Okay. So in that way, you have to do the mapping and you have to control the movement of this M1 and the M2. Okay.
Start. forward, stop, backward, stop, forward, stop, left, stop, right, stop, backward, stop, forward, stop,
Okay. We still have 10 minutes of time, so in 5 minutes I can complete this one. Similar to that one, we can also have develop control systems using EMG signals. EMG means electromyogram signals. Uh, that means from the muscles we can generate the control signals. So we have the surface electrodes. Yes, in my last class I told you that usually for rehabilitation purposes we use surface electrodes, and what you call this invasive electrodes, they are very commonly not used in application purposes because you need a very specialized and trained personnel to place the electrodes, and it is usually not possible for um, the persons everywhere to place the electrodes in a proper place if you want to extract the specific signals. In such a case, what happens is that non-invasive surface electrodes, they are being used mostly for developing this kind of system. So we have the surface electrodes, we have the reference ground. I already told you that any kind of system they should have a reference. Then using the biopotential amplifier, which is basically an instrumentation amplifier with some modifications. Then you do some manipulations over here, signal manipulation to band limit the signals and all these things. Then the signals are being fed into the Arduino microcontroller, and through that we take the signal into the PC, and then we can process it. Okay. Then after processing it, why do you want to process it? We want to process it because we want to look into the amplitude levels when the different muscle activities are being performed. When I say thumb flexion, when we are flexing the thumb, a certain group of muscles are getting activated. When I say that middle finger flexion, then certain groups of muscles they are being activated. And when we perform all these different kind of activities, the muscles which are being activated, they are being activated in a different manner. So the potentials that will be generated, it will be different. Okay, so in that case we can get the range of the maximum amplitude points, and from there we can assign some control values over here. Okay, now once it is done, once the information is with us, then we can take the same module, we can do all the processing in the microcontroller, and we can generate the control signals from there itself, and that can be wirelessly sent to the uh, robotic vehicle. Again over here if you see, we have the motors which need to be controlled, so the movement of the motors, they have been shown over here. Okay, so it is basically pretty similar thing. Once you have classified the signal and you have what you call generated the control signals, then from there onwards, basically the programming for the hardware, it remains essentially the same. Okay.
middle section, corner section, all the innervation.
Okay, then for today we will be stopping over here. If you have any questions, we can discuss. No?